Hi, I'm Chris Anatelio, and I'll be your instructor for this session. I work in developer relations at Infura. I've worked in software engineering for 12 years, and I've produced many technical education videos for the LinkedIn Learning platform. Infura is a major blockchain infrastructure provider for the Web3 ecosystem and is also part of the Consensus product portfolio, along with MetaMask and Truffle. Okay, so what are we going to learn? We're going to learn the fundamentals of non-fungible tokens, also known as NFTs. We will go over some high-level concepts such as blockchain, smart contracts, and NFT use cases. Then we will go through a brief overview of Web3 dev tools used to create decentralized applications, or DApps. We're going to work with some platforms such as Ethereum, Infura, MetaMask, and IPFS. And then finally, we're going to show you how to mint a new NFT. Okay, so what really is an NFT? First of all, it's way more than just a JPEG. An NFT represents verifiable ownership. You can programmatically verify that someone owns a specific NFT. Anyone can verify your ownership of that NFT by querying the blockchain. Think of it like a public database of verifiable ownership. NFTs are very flexible. An NFT is kind of like a wrapper around metadata and can represent anything that can be represented digitally. Now let's talk about the concept of programmable ownership. Let's say an organization owns assets that require multiple approvals to transfer. Normally, this would require a business process requiring manual oversight. An NFT allows you to programmatically ensure that multiple signatures are required to transfer that asset. Another example is automatic royalties paid to the artist for music when it's sold. We could even use NFTs to identify Microsoft MVPs to grant them special access to resources or discounts to conferences. External Microsoft partners could even use the same system without needing to build out a proprietary API. NFTs can represent pieces of art or music. They could also represent ticketing solutions that are resistant to counterfeiting. Additionally, NFT tickets could grant you access to an event, but also represent a collectible piece of memorabilia. A company could also use the NFT ticket to identify users that might be interested in similar events so they could be sent special offers. In the metaverse, NFTs could represent a deed to virtual property, for instance, and even store loyalty programs could be represented by NFTs. Now let's take a step back and take a very high-level look at what a blockchain is. Blockchains have similarities with distributed databases such as NoSQL. Most blockchains like Ethereum are robust, decentralized, global, and publicly available stores of data. While some enterprise blockchains can actually be private, most are public. Blockchains operate on community-managed hardware, but there's potential for bad actors to abuse the system. So blockchains need some sort of mechanism to disincentivize bad actors. Consensus mechanisms such as proof of work and proof of stake help prevent manipulation of data in the network. Proof of stake requires node operators to deposit digital currency that can be taken away in the case of misbehavior. This makes it so node operators are accountable since they have to invest non-trivial amounts of their own resources into the process. These mechanisms make it so it's not economically viable for bad actors to exploit the network profitably. Ethereum's major innovation in the blockchain space is the ability to run what's called smart contracts. Instead of a blockchain just being able to keep track of a simple transaction, smart contracts allow for more complex state changes. These smart contracts open up a whole new world of possibilities, including NFTs, decentralized finance, decentralized autonomous organizations, and much more. So, how do you write a smart contract? On Ethereum, the primary programming language used is called Solidity. Smart contracts combined with a front end are called decentralized applications, or DApps. Smart contract front ends are built with standard web development technologies like JavaScript, CSS, and HTML. Libraries such as Web3.js are used to interact with the blockchain. Then we have frameworks for building DApps such as Truffle. Truffle will provide you with local dev tools, a testing framework, and will help you with deployments. We will be deploying our smart contract to a testnet. A testnet is a non-production version of the blockchain. Infura helps DApp developers build applications that could scale by providing rock-solid, scalable blockchain node infrastructure. And by the way, Truffle also has an extension for VS Code. Finally, you will need a wallet to sign and execute transactions. We will be using MetaMask. Now let's put theory into practice. Go ahead and clone this GitHub repository to follow along. First off, we need to set up our development environment. You will need Node version 16 or higher, and we will be using VS Code as our IDE. Finally, you are going to need the Git CLI. Next up, we need a wallet. Check out this Getting Started guide to get your MetaMask wallet set up. Be sure to take a look at the MetaMask FAQ for any other questions. We will need to deploy our smart contract to a testnet, and we will need to upload our artwork for the NFTs to IPFS. IPFS is a decentralized cloud file storage solution. We can sign up for a free account with Infura to carry out these tasks. Navigate to infura.io and click sign up. Then you can check out this Getting Started guide for more info on setting up your Infura account. Before we mint our NFT, we first will need to upload an image to IPFS via Infura. Infura offers a IPFS file upload tool that we could use. Keep in mind, this tool requires the Go programming language. If you can't install Go, you could always use the IPFS API methods listed below. So first, let's git clone the project locally, and then cd into that project. Then let's build the project. Next, we call the IPFS upload client, passing in 3 arguments: the project ID, the project secret, and the path to the file to be uploaded. We will then get a hash representing the location of the file that we could reference in our NFT metadata. You can access the uploaded image directly using the URL displayed below with your hash value substituted in. Okay, so let's pull down the NFT Crash Course project using git clone. Now let's cd into that project directory. Then let's create a .env file and enter in our project ID, secret ID, and the wallet mnemonic from our local MetaMask wallet. Be sure to never use a wallet with anything valuable in it for development. Next, let's import the project into VS Code. Then let's open up the Truffle config file. On line 23, we have our Infura testnet endpoint that pulls our project ID from the .env file. The network section on line 37 allows us to configure our deployment targets. On line 44, we have our local deployment target. And on line 60, we have our testnet deployment config. So we are going to need some testnet ETH in our MetaMask wallet to deploy our contract and to mint our NFT. Faucets are community resources that give out testnet ETH for free. Let's navigate to app.mycrypto.com/faucet. Link your MetaMask wallet. Go ahead and connect. Then click Tools, Use Testnet Faucet. Select your wallet then click Request Assets. As you can see, the transaction is pending, and it might take a couple minutes, but soon you should have testnet ETH in your wallet. Alright, now we're going to deploy our smart contract to testnet. But first, let's open up our .env file and add in two more properties. Let's add in the IPFS, project ID, and secret. Next, let's open up VS Code and open up the mynft.json file in the metadata folder and update the external URL and the image field with the IPFS location of our image. Okay, and go ahead and save. Since we already added our deployment info to the Truffle config file, Truffle will handle the details of our deployment. Now, let's go back to the command line and execute truffle migrate --network rinkeby. This command will deploy our smart contract to the testnet rinkeby. Okay, so if you have your wallet mnemonic set up, your Infura project ID and secret set up, then your contracts should go through the deployment scripts and they should deploy to the testnet successfully. So you can see here, Truffle is running through the migration scripts, and then we need to broadcast that transaction to the actual blockchain. And remember, every transaction on the blockchain costs money in the form of the native digital currency. In this case, Ether. So as you can see, the act of deployment is actually a transaction in and of itself. Hooray! We have successfully deployed a smart contract to rinkeby. Be sure to get the deployed contract address because we are going to need that to mint an NFT. Now we are going to actually mint our NFT. But first off, let's add a couple more constants to our .env file. Let's add in the contract address, which is the address of the deployed NFT smart contract on rinkeby. Now let's add in our public address, which we could grab from our MetaMask wallet. And then finally, we can add in the token URI. Now let's open up VS Code and take a look at our Solidity smart contract. Let's open up the mynft.sol file in the folder contracts. Basically, we are extending functionality from an existing contract provided by OpenZeppelin. OpenZeppelin provides reusable, audited, battle-tested smart contracts for developers to use. The contract we are using implements the ERC 721 spec, which defines NFT smart contracts. Now let's check out the script we are using to mint an NFT. Let's open up the file mintnft.js in the folder scripts. We can see on line 3 that we import our config from our .env file. Then we retrieve an instance of the deployed smart contract via the contract address on lines 10 through 13. Then on line 19, we execute the mint NFT function, passing in our MetaMask wallet address and the token URI. Finally, we handle the result and print it out to console. Now let's execute the script and mint our very first NFT. Let's execute that script. And pass in rinkeby for the network. So that script uses our wallet to actually execute that transaction and mint an NFT. It then gives us a URL where we could look at details of that transaction. we can decode that input info, and we can see the URL of our image here. You can also check out your NFT on testnet.opensea, which is a platform for NFTs. Now that you have some foundational knowledge about NFTs and Web3, it's now your turn to start your developer journey into Web3. Thank you for watching. Be sure to check out our external resources for additional learning opportunities. Connect with me on social media if you have questions about your Web3 developer journey.